Thank you. Good morning, South Africa. Good morning. Actually, I'm thrilled and honored to be here with you for this great event. It's the second time I'm here in South Africa, and actually the second time I'm here in Johannesburg. The first time was approximately 20 years ago. And when I drove from the airport to the venue, I realized, things have completely changed here. I didn't even know, it was the capital of South Africa now. Right, so let me begin by looking a little bit to our future. But let me start today. Today, there's about 7.5 billion people living on this planet. By 2050, there will be 10 billion of us. All around the world, the middle class is growing at a faster pace than ever before. In 1990, less than 25% of the world's population earned enough to be classified as middle class, right? That's just a few years ago. Now, today, almost half of us do. That's 3 times as many people whose lives have become better. And that's just the start. 400,000 people are joining the middle class each and every day. And with this growing population, of course, there comes growing demand. As an example, 400,000 new people every day will desire and deserve everything that we do. Smartphones, cars, sufficient food, and of course, housing. By 2050, more than 2/3 of us will live in cities. 2/3 of us. And as a result, we'll need exponentially more buildings than we have today. And what we have to spend for this is just a fraction of what we have to invest in new infrastructure. Not even to mention the cost of repairing our old and crumbling infrastructure. So in other words, we sort of need to rebuild or need to build this new world while continually rebuilding the existing one. Think about it. Highways, hospitals, education, and energy, water, right? And wheat. 10 billion people will want what we all want, and that's more. More is inevitable. And the demand for more is actually driven by demographic changes that are already underway. To meet this increasing demand, we become increasingly reliant on automation. But more demand doesn't necessarily mean that we create more job or more equality. So as we make more things for more people, there's one thing. We also increase the potential for more negative impact. This negative impact is often the unintended consequence of the things we make. The more we make, the more we will consume our limited natural resources. And the more we make, the more we will tie up our limited skilled labor pool. That is especially true in industries like construction and manufacturing, where already today we do have less skilled workers than needed. So how do we build all the things we need and balance this with less negative impact. Less negative impact to the people, less disruption to the business, less harm to our communities, and less creation of inequality. Also less negative impact on the planet, less depletion of our natural resources, less waste, and of course less carbon emissions. As we plan for this inevitability of more, how do we balance this with the reality of less? How can we balance this? In order to solve this fundamental capacity issue, we need to fundamentally rethink how we make things. We just cannot continue the way we are making things, we are doing things today, when the construction industry creates almost 1/3 of all global waste. 1/3 of all global waste produced by the construction industry. And 70% of all the spare parts we make today aren't ever needed. 70%. So we are wasting a lot. We are wasting warehouse space, we are wasting material, we are wasting energy, and we are wasting time and money. So reducing our negative impact on the people and on the planet is a reality we all need to own now. And addressing this inevitability of having to do more with the reality of doing it with less impact is a massive design challenge. But addressing this capacity issue, this fundamental capacity issue, is also the biggest design opportunity we've ever had. At Autodesk, we make software that helps our customers to address these design challenges every day. So how do we make better things? Things that are better suited to their use and to human needs. I think here in this room you all agree that the things we have today do not necessarily meet our needs and our desires. Mass production has actually given way to mass customization. The things we make today contain software and sensors, contain microprocessors and media. They are more connected and more configurable. And now we have the opportunity to also make things that are more meaningful. So, what about how we make things? What role can automation play to help us make things better? In the last several years, a proliferation of new advanced manufacturing capabilities has changed what we can make. And the things we make today are no longer constrained to the physical process of making. Robots are no longer constrained to the factory. In fact, we see them move from the production line to the construction site. Also, 3D printing is no longer constrained to prototyping. We are seeing, for example, in the automotive or in the aerospace industry, that additive manufacturing is increasingly production proven. So we are capable of making things of higher complexity and of higher fidelity. And now we also have the opportunity to make things of higher value, things that perform better and last longer. So how about the work we do? The things we make today, as I said before, are more connected, and so are our industries, and of course, also our supply chains. The things we make today are more configurable. and we are less constrained to that physical process of making. The way we design and make things across all industries, the ways are converging. Right? Automation has given us the opportunity to make things that are more meaningful. And now we have the opportunity to use automation to create these things in a more meaningful way. But automation is not just changing how we work, it's also changing what we work on. It's changing the things we are capable of making. And it's helping us to make things better. So, what do better things actually look like? And with this, I would like to use an example from General Motors. The things General Motors makes have changed a lot over the last 100 years. And so has the work on their assembly line, of course. For over 100 years, General Motors used automation to optimize their production, to the point where today a new car rolls off their assembly line every minute. And each of these cars contains over 30,000 individual parts. But optimizing production is no longer enough for General Motors to keep pace with the rapidly changing auto industry. So its CEO, Mary Barra, is helping General Motors to reinvent itself by reimagining their business around electric. She has committed to bringing 20 new electric models to market by 2023. So 20 models. And that means, of course, increasing efficiency. And the best way, as you know, to do this in automotive is by reducing weight and reducing complexity. So General Motors is using Autodesk's generative design technology to massively reduce the number of parts that go into each of their cars. And at the same time, they want to make them lighter and stronger. Our generative design tools allow their engineers to design solutions based on their goals and their constraints. As an example, where they connect to others, what they're made of, or what loads they need to take. General Motors has worked with us on a prototype for exactly this part. This is a bracket into which the rear seat belts fasten. With the defined goals and constraints, generative design automatically generated dozens of viable design solutions for General Motors to choose from. At the same time, it considered performance and manufacturing viability, which meant in the end that General Motors engineers were able to scan and explore dozens and dozens of viable design options much faster than they'd previously been able to for any single part. From all the design options, you can see here, the one they finally decided upon was this one. Looks quite weird, doesn't it? This is a solution which previously would have been impossible to make for any human, right? To design for any human. Yet a human did, in partnership with generative design, but just defining the constraints and the task of that model. A solution also that General Motors designed to be 40% lighter and 20% stronger than the original part. And above that, this part can now be printed as a single part, as a single element, rather than assembled from 8 different separate components. So generative design is enabling General Motors to create parts that are more lightweight and of course more fuel efficient. And less parts in the end also means less complexity and less suppliers, of course. But automation is not just changing what General Motors can build, or what part, how they can make the parts. It's also changing their vehicles, it's changing their supply chain and their complete ecosystem. And General Motors' focus on innovation helped them to improve this bracket. But that's just one part, right? So just imagine how much further automation could take GM. How much further all of their cars would be able to go with the same amount of fuel. Also, how much fuel could be saved if General Motors would apply generative design to all of the thousands of parts which go into each one of their cars. Let's turn next to the things we build. So how can making better homes result in a better business model for construction? That's precisely the question that one of our customers has been asking themselves. That's Van Wijnen, a family business in the Netherlands, which builds a lot of property, including net zero energy housing, affordable net zero energy housing. Now, building housing that's affordable and at the same time sustainable may sound a bit paradoxical to many of us, but not to Van Wijnen. They are not like many companies in the construction industry. But like many companies in the construction industry, after the last downturn, they were very concerned that their 2% profit wouldn't be something that could sustain them. They only made 2% profit, like many companies, by the way, in that business. So by fully adopting building information modeling, they figured out ways how to eliminate waste and to drive down cost. And tagging all of their components with all the metadata they needed enabled them to think more like an automotive manufacturer. Where today, they can design and develop modular housing concepts which then later can be reused in many different configurations. And having invested in this catalog of component parts, they use manufacturing processes to make those things better. They are prefabricating basically all of the parts themselves. First, they started doing this off-site at their own factory. Later, they moved this on-site at any construction site they could fabricate the parts. And soon they were able to just build and assemble the houses in just 3 days. And after they had reimagined the way they approached building the houses, they started to think about how to design them. So we supported them in another project using generative design technology to explore over 15,000 different design options for the same setup. So the one they finally decided upon was this. This is sort of a setup which they used and they decided on, for this 15,000 options, which they then could shape into the perfect urban neighborhood. Generative design helped them to look across multiple design options all at once, as you can see here. And what it helped them is, for example, to maximize the amount of solar energy they were able to collect. So this could also be then combined and aligned with other key metrics, as you can see here. For example, they were able to optimize the size of the backyards or the views to better meet the human needs of the occupants. Just to give you an idea how this worked. So this is really scanning through all the design options. So Van Wijnen's modular system helped them to make houses better, make buildings better, with less waste and less risk. While generative design helped them to make better buildings with more yard space and also more daylight, just to support the human needs of the occupants. But automation is not just changing the things that Van Wijnen makes, it's also changing the jobs of the people who work there. It's changing how they approach design and also creation of new concepts. It's also changing the job of the people. The concept of modular construction wouldn't simply be effective without making houses in ways that are more industrialized, using prefabricated components manufactured to be more modular. So they can quickly be assembled, of course, on site. That's the important thing. The concept is actually built on both. Number one, repeatability. Number two, flexibility. So they converged the repeatability of manufacturing with the flexibility of construction. And because the process that drives this concept is fully digital, it's completely changed the nature of work at Van Wijnen, where human innovation is now thriving because of this new partnership with automation. Let's go back to General Motors for a moment. The things that General Motors is making are also changing a lot because of automation. The next generation of cars, of vehicles, relies heavily on lightweighted parts, as I said before. And that just wouldn't be possible without making those parts in entirely new ways. Generative design and industrialized additive manufacturing are completely changing the parts or how parts are designed and made. In doing so, also changes what General Motors is capable of making. It changes the nature of the work. Actually, for over 100 years, automation has helped the car industry to focus on optimization. And this new relationship with automation now helps them to focus on the thing they really should do, and that's innovation. So as you think about what automation can do for you, do not just think of automation as a way to improve the bottom line, as it might also help you to grow your top line. Sure, automating tasks and optimizing processes are key parts of what we all have to do to stay competitive. Whether optimizing for efficiency or for density, optimization is what we all need to do and what we all do in order to simply keep up with our competition. But it's actually imagination, not optimization, which makes us all move ahead. Whether imagining how a single part can be printed, right, rather than assembled from many different components, or imagining how to accommodate the needs of human beings with the business needs, automation takes us further. And just imagine how much further we would be able to go when we partner our human imagination, our human innovation with automation. We have seen how far our innovation around generative design can take your work when we see what we've done over the last 7 years with generative design. We've seen how it's changing not only what you can design and make, but also how you design and make. But we know, of course, that you're now not all going to retool around additive. That's not going to happen. So we're working on how we can help you to explore how to make any design across the full manufacturing spectrum, from milling to molding, from casting to composites, all from the same design space. We want you to be able to manage a portfolio of viable design options rather than managing a portfolio of features. And our vision is to enable you to explore the full solution space and have a clear line of sight from part to production. As we change how you design by converging on one solution from many different options and guiding the tool to any manufacturing method, we recognize that we also change how you learn. So, thinking about how tools for design through co-creation can also foster learning through co-creation. In other words, learning tools built on automation that, like generative design, anticipate your needs and help you nurture innovation. As such, we can balance the inevitability of more with the reality of less, and at the same time, look for the opportunity of better. Better things, better work, and a better world. Through human innovation and automation, we can definitely shape the world around us. Because working together, we can make anything. Thank you very much.